Alright, I recognize that these are some of the harder problems in this chapter. If you have to rewatch this video to get the understanding of what we need to do here, then make sure you do that. I am going to be pausing a number of times that you may or may not recognize to try to redraw and kind of copy over a lot of the material that's going on here. So kind of bear with me, and if you need to pause it, rewind it, or rewatch it, please do so. So in this figure we have technically three different triangles. We have our big triangle, we have these two smaller triangles, and the key to this is probably going to be able to draw those triangles out. So the first thing I'm going to do is kind of draw out that big triangle. If I just kind of move that, all I'm doing is taking the outside part of this. And now make sure we label it accurately. When I just pulled that away, this was A, this was B, this was C, this was my right angle, AB is X, BC is 40, and then make sure you put this whole side length in. That's a segment addition problem. Hey, you have an 18 and you have a 32, you add those together, you have a 50, this is a side length of 50. It's going to be important that we have all of that stuff labeled. Now I want to redraw my two smaller triangles, so I'm first going to pull that small triangle in the top out. And again, notice what I'm pulling. You have A in the top, then you have D, and you have B. So when I pull those out separately, make sure we label them accurately. We had A, D, and B. A, B is still X, A, D is 18, and D, B is Y. Your right angle this time, because we didn't take this whole right angle from B. Your right angle is up here at D. That's important. Now the one thing I hadn't done yet is I also like to number my other two angles in the big triangle. Angle 1 and angle 2, for example. Because when I pulled that big triangle out, that's going to help us in naming our triangles. Angles 1 and 2. But I didn't pull angle 2 out with this small triangle. I only pulled angle 1 out to here. That's going to be important. And when I pull this third triangle out, notice I'm not going to be pulling angle 1 out, but I am pulling angle 2 out with me. And then again, labels. D was up here, C was down here, and B was down here. So make sure we have those labeled. There's D, there's B, and there's C. And my right angle, once again, is going to be up at D, because I didn't pull the whole right angle from here. DB is Y. DC was just the 32 portion, and this BC was 40. I'm going to go put this angle 2 back in there. Now I've given you the name of one triangle. I've named one triangle, triangle BDC. That's this triangle here. That's going to be where we're going to kind of jump off from. This is triangle BDC. I need to do this before I can do this. That means I have to name my other two triangles. I like to put those angle numbers in because that's going to help me with the naming these triangles now. As I look at this, what I've named is I put angle B first, angle D second, and angle C third. That's what was given to me. Well, what angles are represented there? Angle D, that's my right angle. Angle C, that's my angle 2. Well, that must make angle B my angle 1. Because I have to have a right angle, an angle 1, and an angle 2 in all three names. That's helpful because that's exactly how I'm going to name all of my other triangles, or both of my other triangles. When I am naming this triangle, I want to use the exact same order. I want to use angle 1, followed by my right angle, followed by angle 2. And then I want to do the same thing here. Angle 1, right angle, angle 2. Angle 1 in this triangle is A, so I call this triangle A. Right angle is B, and angle 2 is C. So, triangle ABC. Here, angle 1 is A, the right angle is D, and angle 2 must be B. I have triangle ADB. Now I can solve for x and y because I have three similar triangles. These are similar triangles by angle-angle similarity. You can tell they have a right angle, angle 1, right angle, angle 1. Those are similar. That's the same angle 1, two congruent angles. Right angle, angle 2, right angle, angle 2, these are similar triangles because of angle-angle similarity. Now I have proportional sides, and that's where all of my other side lengths are coming into play. So just to represent what that means segment AB corresponds in this triangle to segment AD, which corresponds in this triangle to segment BD, because they're first and second in all of them. Okay, well, segment AB here is X, segment AD is 18, and segment BD is Y. I want to go through and figure that out for all three of my sides. AC, segment AC corresponds, first and third, to segment AB, which corresponds to segment BC. I'm just going to move everything down slightly here. Too much. AC is 50. AB is X, and BC is 40. And then lastly, we did AB, we did AC, now I have to do BC, which corresponds, second and third, to segment DB, which corresponds to segment DC. And again, coming up with my sides, BC is 40. I'm just going to write it to the side. DB, D to B is Y, and DC, D to C, is 32. I can solve for X and Y based on this information because what I can do is set up my proportions. So I know, looking for things that they have in common, two of them. I just want to pick two triangles, like AB has an X, AC is 50, AD, which corresponds to AB, and AC corresponds to AB, is also X. Those are corresponding parts. I can set up that proportion. X over 50 equals 18 over X. Cross multiply and solve. X squared equals 50 times 18 is 900. Square root both sides, and X is 30. So I'm finding X by setting up those proportions. To find Y, I do the same idea, but make sure you're using only Y. You're not going to use a piece with X in there. What I mean by that is I know DB and DC correspond. That has Y. So now I'm using triangle ADB and triangle BDC. If I use those two triangles, I don't want to use AB and BC because that has an X in it. I could because I now know what X is, but it might be easier to just go and use AD again, which corresponds to BD. Now, 18 over Y is equal to Y over 32. I can solve that proportion. Y squared equals 576, square root both sides, and Y is 24. It all comes from pulling out your triangles and then identifying corresponding parts to set up your proportions.